5 Facts about Planet Earth. A quick guide. Earth, Terra, Earth, Erd, all nations have different names for the same world in which we all live. Having visited all the known worlds of the solar system, we have sincerely begun to realize how unique our own world is. In this review, I will introduce you to little-known facts about the unique physical and climatic features of our stone giant that determined our very existence. We all know the main features of our planet that we have not yet been able to observe on other planets, namely oceans of liquid water on the surface and, of course, the existence of life. However, many will be interested to know about the other unique features of our planet, which made the existence and evolution of life on it possible. Number 1. Iron and Stone Giant. The planet Earth is not only the largest of the rocky planets in the solar system, but also the most massive in the solar system. Larger does not always mean more massive. The mass of the Earth is estimated at 5.97 x 1024 kg, while the mass of its sister Venus is less by 1.1 x 1024 kg. To increase the mass of Venus to the mass of the Earth, we would not even have enough material of Mercury, Mars and the Moon taken together, 5.861024 kilograms in total. And only by adding to this planetary solid Ganymede, the largest and most massive satellite of a planet in the solar system, Jupiter, we could outweigh the stone giant. And that only by 0.5%. A similar difference in mass is achieved by the fact that the Earth is also the densest planet in the solar system, 5.51 g/cm3. The freefall acceleration, g, at its equator is similar to that at the imaginary surface of most giant planets, except for Jupiter, where g is 2.5 times greater. Speaking of the principle, bigger does not mean more massive. Ganymede is twice as massive as the Moon, and its diameter is 8% larger than that of the planet Mercury, 5,300 kilometers versus 4,900 kilometers, but it is more than twice as massive as the latter. Number 2. Natural nuclear reactor. Almost all amateurs of physics and related sciences, such as astrophysics, are familiar with energy sources in stars like the Sun, where the thermonuclear fusion reaction of hydrogen and helium nuclei takes place. Active processes of production and transfer of energy also take place inside large planets, but through diametrically opposite processes. During the formation of our planet, the heaviest and densest elements, such as iron, nickel and radioactive isotopes, were sinking in the center of the planet, while the lightest remained closer to the surface. Thus, there was a differentiation of the inner layers of the planet. Therefore, large celestial bodies are characterized by relative scarcity of heavy elements near their surface, one of the main reasons for the interest of Earthlings in Mars. As a result, an iron-nickel core was formed in the center of the planet, heated by the decay of radioactive elements to 5,700 degrees Celsius. Earth's interior, 1 to 2 inner and outer core, total mass of 28.5 lunar masses in 3 mantle, 52 lunar masses. The Earth's lithosphere, 4 together with the hydrosphere and atmosphere make up no more than 1/3000 of the planet's mass. All this heat is released through the liquid outer shell and passes into the mantle. The movement of molten metal in the outer core itself generates the Earth's magnetic field. Through convection processes in the mantle, energy reaches the Earth's crust. The continental drift we know is the result of constant movements of the lithospheric plates that make up the Earth's crust. In other words, the Earth is not just a giant lump, showing activity only at the surface, but a colossal nuclear reactor, with active heat release systems and powerful magnetic field generators. Number 3. Magnetic shield. The aforementioned magnetic field of the Earth is also not typical for the planets of the Earth group. More precisely, the magnetic field of the same nature was found in Mercury, but the Earth's magnetosphere by its characteristics is more similar to the magnetospheres of the giant planets. By its strength at the equator, it is inferior only to Jupiter, 10 times, surpasses Saturn and Uranus, and comparable to the strength of the magnetic field of Neptune, 0.3 GS at the equator. However, it is significantly inferior to all of them in terms of magnetosphere size and dipole magnetic moment. Schematic of the Earth's magnetic field. Ionosphere appears at ionization of molecules of upper atmospheric layers by solar radiation. It is present in almost all planets with relatively dense atmospheres and can deflect part of the charged particles arriving from the surface of the Sun. In contrast to the magnetospheres of the giant planets, the Earth's magnetic poles do not correspond to the geographical ones. The northern magnetic pole of our planet is located in the southern hemisphere, and the southern one, respectively, in the northern hemisphere. The reasons of such geographical location of magnetic poles are in their constant inversions in geological time scales, connected with chaotic processes in liquid external core of the planet. The magnetic poles, traveling along the Earth's surface, alternately approach the geographical poles of the planet. The whole process takes from 1000 to 10,000 years, during which polar auroras in certain periods can be observed at any latitudes of the planet, up to the equator. During such inversions, the magnetic field of the planet temporarily weakens, which may lead to an increase in the radiation background on the surface of the Earth. Nowadays, magnetic poles travel over the planet with increasing speed, more than 50 kilometers per year these days. Inversions of magnetic poles of the Earth for last 5 million years. Black color designates inversions similar to modern. White color, periods of reversion. Magnetic poles lie in the corresponding geographical. Scientists have no data on positive correlation of weakening of a magnetic field at its inversion with mass extinctions of species. However, in any case, such weakening of the magnetic shield of the Earth will not catch mankind unawares. The last time the magnetic field inversion occurred about 780,000 years ago. If Homo sapiens arose 240,000 years ago, it means that our species has never experienced geomagnetic inversions. Thus, the majority of scientists agree that process from the beginning till the end takes some thousand years, from 2 to 3 to 7 to 10,000 years. At the same time, however, the most active stage may occur within a 1,000-year time interval. On the other hand, some experts believe that some reversals in the history of the Earth could last tens of thousands of years. In any case, it's not years or decades. See, the most popular scenarios of the end of the world in December 2012. Number 4. A month of stability. If chaotic processes in the Earth's core cannot guarantee a stable orientation of the Earth's magnetic field dipoles, our planet's natural satellite has been providing a stable orientation of its geographical poles relative to its orbital plane of rotation around the Sun at an angle of 23.5 degrees, varying within 3 degrees with an interval of 100,000 years, for 4.5 billion years. Such stability of the planet's axis of rotation is capital to provide relatively constant conditions for the evolution of life on our planet. For example, the planets Venus or Mars are doomed to chaotically change the angle of the axis of rotation to the plane of rotation, under the influence of the tidal forces of the major planets and the Sun. However, the axis of rotation of the Earth is subject to the so-called precession. The rotation of a celestial body is characterized by its motion around its own axis of rotation, while the rotation expresses the actual motion of one celestial body in orbit around another celestial body. Thus, the Earth does not revolve around the Sun, but in the 365 daily rotations of the Earth. The existence of such a heavy stabilizer in the orbit of our iron and stone giant, as well brings it closer to the gas and ice giants. The Moon has a transverse diameter of 3,476 kilometers and is the fifth by mass satellite in the solar system, after the largest satellites of Jupiter and Saturn. Its matter would easily be enough for 5 planetoids the mass of Pluto, and the remainder would be enough for 2 more asteroid belts between the orbits of Mars and Jupiter. The Earth-Moon system has the lowest mass ratio of a planet and its satellite in the solar system, previously belonging to the Pluto-Haron system. The Earth exceeds the Moon only 81 times in this respect. For example, Saturn exceeds Titan in mass by almost 3,000 times. Number 5. A universe the size of a pitchfork. The Earth's large mass, combined with a powerful magnetic field and a large natural satellite, have made a major contribution to the climatic diversity of our planet. Many people remember how in the fantasy sagas the heroes traveled through different worlds in which only a certain type of climate dominated. These include the rocky planets Vulcan from Star Trek, hot Tatooine, frozen Heth, and the forested companion of the giant Ender in Star Wars. Of course, this is only a simplification by the authors, and inhabited planets can exhibit great climatic diversity, just as they do on Earth. On our ironstone giant there is room for a whole universe of all kinds of landscapes, both boundless oceans, impenetrable forests and jungles, and, of course, the endless dazzling ice of the poles. On this final, but not the last, amazing and unique feature of our planet, I would like to end this brief review. However, it would be more correct to give the floor to Carl Sagan, who left us long ago, but who left a solid intellectual legacy. Take another look at this point. This is it. This is our home. This is us. Everyone you love, everyone you know, everyone you've ever heard of, everyone who has ever existed has lived their lives on it. Our many pleasures and sufferings, our thousands of self-righteous religions, ideologies and economic doctrines, every hunter and gatherer, every hero and coward, every creator and destroyer of civilizations, every king and peasant, every couple in love, every mother and father, every capable child, inventor and traveler, every ethics teacher, every lying politician, every superstar, every greatest leader, every saint and sinner in the history of our species lived here on a speck, suspended in a sunbeam. Earth is a very small stage in the vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors so that, in a ray of glory and triumph, they might become the short-lived masters of a speck of sand. Think of the endless atrocities perpetrated by the inhabitants of one corner of this point over the barely distinguishable inhabitants of another corner. Think of how often they disagree, how eager they are to kill each other, how hot their hatred is. Our posturing, our imagined importance, the illusion of our privileged status in the universe, all fade before this point of pale light. Our planet is but a solitary speck of dust in the surrounding cosmic darkness. In this grand void there is not a hint that anyone will come to our aid to save us from our own ignorance. Earth is so far the only known world capable of sustaining life. We have nowhere else to go, at least not in the near future. To visit, yes. To colonize, not yet. Whether you like it or not, Earth is our home now. Astronomy is said to instill humility and build character. There's probably no better demonstration of stupid human arrogance than this detached picture of our tiny world. It seems to me to emphasize our responsibility, our duty to be kindred to each other, to keep and cherish the pale blue dot, our only home. The pale blue dot.